All right, so we are in for vectors, and that is our lesson 2. Now, our lesson 2 is about the dot and cross product of two vectors, the dot and cross product of two vectors. Now, to begin with, let's start with part A, that is dot product, or another name for it is a scalar product. It's because when you dot two vectors, we get a scalar. All right, so we are now saying when you dot two vectors, you get a constant, i.e. a dot. Now a dot is written like this. A dot b is equal to k, but a dot is several times means to multiply. That's what it means. Okay, now a dot b gives us k. K is a constant. That's what I'm meaning. The word constant, scalar, they are the same. And the constant can just mean like a counting number, like 2, 3, any counting or any natural number is a constant apart from a 0. Okay. Even a 0 can be a constant, you never know. Okay, if A vector is equal to x, y, z, and B vector is equal, please, these wave lines are important, is equal to P, Q, R, find A dot B. Now, I want to find A dot B. How do we dot them? So, we shall say, in our solution here, we shall now say that A dot B will be the same as, now you get their corresponding vectors. So, this space be enough for me. You get their corresponding vectors. Okay, I'll put it here. You get their corresponding vectors, that is x, y, z. Then you also bring a dot. Okay, the other vector is p, q, r. Now, when you're dotting, in simple terms, here I'm using demonstrations, then I will go to real question here, where I have numbers and see the way to go. When you're dotting, the number up multiplies with that, this multiplies with that, this multiplies with that. That's what you do. So, x times p is xp plus, as you're going down the rows, you add y times q is qy plus, as you go down the rows, you add z times r is zr. And realize that if these were counting, if these were digits, then you realize that the answer you get finally is a constant or a scalar. Okay, now let's have the real example here and see. They want if a is equal to that and b is equal to that, then they want us to dot a dot b. So therefore, here we shall come and say that a vector dot b vector is equal to, right, we have a 1, a 5, and a 3 dot, okay, we have a 6, 7, and a 1. This will give us, now we dot this times that plus this times that plus this times that. That's what we simply do. So now that will be 1 times 6 is 6 plus 5 times 7 is 35 plus a 3 times 1 is a 3, like that. Then what will be our final answer when we try to add here? A 6 plus 31 will be 41, plus 3 will be a 44. A 44. Now, are you saying that this one is a constant? You had vectors originally, but you are ending up with a constant. Take note. When you do two vectors, you get a constant, or you get a scalar. And that's how simple we dot. Please, you have to note, or you have to know how we go about dotting. The next examples will be calling for some of these parts. All right, so let us now go to the mighty. I'll put here a star. A star. It's very, very important in vectors, by the way. This one is very, very important in vectors. So, cross product. They're saying when you cross two vectors, you get a vector. Here, you cross two vectors, you get a constant. Then, rather, here, when you dot two vectors, you get a constant. Here, when you cross two vectors, you get a constant. A bit interesting. Now, they're saying, if you have a cross, and how do you write the cross? You write a multiplication symbol is that which shows a cross. Please, this one shows dotting, and that's how we go. Here, a cross b. That's how we write it equals to a vector. We have an example here. Vector A is that and vector B is that. Find A cross B. So we shall now say vector A cross vector B is as good as X, Y, Z. Okay. Cross, you put a cross like that. P, Q, R. Like that. Now, what you're going to do here is, in simple terms, we shall have to use a piece of paper. A piece of paper to at least have that done. Let's get a piece of paper and we see how we can do that for better understanding. All right, good. So I have gotten my piece of paper, and now what we simply do is I try to fold it a little bit. We see how we go about the crossing. Please, there are very many methods, but this one, I guess it is a bit simpler. There are two methods. There's this one of this type, whereby then there's the other one of arranging it in IJK format. For us, we shall take this. Okay, good. Now what happens here is our answer will be in those brackets. So what happens here is, if say for example, we want to get the answers for this one up, what you do, you come and cover up this one up like this. After covering up, what do you remain with? We are remaining with YZQR. Now that YZQR, look at it in this format. Look at it in this format, that YZQR. Then you try to get their date, their determinant. You all know that this is the major diagonal, and this one here is the minor diagonal. So this one is Z. Now what you do, determinant is equal to major product in the major diagonal minus product in the minor. So this will be Y times R, YR minus ZQ. Then they can see that. So after covering, the ones which you remain will be a 2 by 2 matrix, more like a 2 by 2 matrix. So what you do, you multiply the major diagonal minus the minor diagonal. So here up we shall have YR minus ZQ. YR minus ZQ. So when I cover up, what remains is I get their determinant. Then the determinant, I put it up. So now I'm going to the middle. I'm covering this middle part. All right, let me refold this paper again so that it may appear a bit smaller. So now I'm going into the middle row. So assuming I have covered, I see what I've covered? I've covered that. So what are we remaining with? We are remaining with XP, then ZR. Now, major diagonal will be XR minus ZP. But what you must note, whenever you're on this middle row, attach there a negative. It is a must to put there that negative by default. It is a must. I'll explain where this negative comes from. Whenever you are dotting, this second row always attach a natural negative. It exists there. So now what you shall do here, you can now start crossing. Now here to be ZR, but I put a negative XR minus ZP. Please, for this second row, you must attach a natural negative there. I'll explain where that negative comes from. Okay, good. Then lastly, I want to go to this. When I'm covering, I cover this, I remain with that. Then it's that to be QX minus YP. So QX minus YP. And with that, I will have crossed the two vectors. You see that I'm ending up with a vector. Why? There's a number up, another number, another number. This is in the X, in the Y, in the Z. So we have a vector again after crossing the two vectors. Please have said there is a natural negative here. I'll explain where it comes from. Okay. Now, let's now go to this part whereby we have the numerical values. Except, for example, vector A cross B will be the same as, let's try crossing, 1, a 5, a 3. Like this, cross. Please, you have to learn this. You have here 6, a 7, and a 1. You have to learn this, how to cross. It is very, very important. Then what are we going to have in the end? So here we said, we go about the covering, you cover here. What are you remaining with? I'm remaining with 5, 7, 3, 1. Get determinant. 5 times 1 will be 5 minus 3 times 7 will be 21. Like that. Good. Now I'm going to this next row. But this next, whenever you're going to the second row, attach a natural negative there and put in the brackets. Whatever you get, put it in the brackets there. So now this will be, when you cover up this, are you seeing? The major diagonal is this, the minor diagonal is this. So 1 times 1 will be 1 minus 3 times 6 will be 18. They are like that. Then finally, I'm moving down, cover up this. So what are we going to have? We have, okay. After covering this, we have the major diagonal is 1 times 7. That will be 7 minus 5 times 6. That is a 30. As simple as that. Okay, good. Now, let's see what will be our final answer. Allow me to put it here. Our final answer. Now I have 5 minus 21. 5 minus 21. I think I shall have a 16. Then here we have 1 minus 18 will be negative 17. Times this will be now 17. Then 7 minus 30 will be a negative 23. Are you seeing it is a vector again? A bit interesting. Now I want to explain where this negative comes from. I want to explain where that negative comes from. and you will allow me to do it from here. You will allow me to do it from here. Now, let's say, for example, where that negative comes from is when we arrange those values in the IJK format, like this one, it will be 5, 3, 5, 1, 5, 3. Then next, the other one is 6, 7, 1. For those who use this method, I want to explain where that negative comes from. So we have negative, it is I, J, and K. Now, you realize that still, even if we have it in this column form, this remains I, J, K. If you can see that, I, J, K, I, J, K. That's the order. And you see that the negative is put on the part of J. All right, now let's see where that negative comes from. Now, what we do is, here we've got rows and columns. Remember, this is the first row, rather first column, second column, and the third column. If you can see that. In terms of rows, this is the first row. Whoever is here is in the first row. Then here, whoever is here is in the second row. Now what we do, we always use negative I to test. We use negative 1, sorry. We use negative 1 to test. Now we would ask, why are we having a positive here? Why are we not worried of this, and we are worried of this area? So we use negative 1 to test. And then on top of that negative 1, we put the row number plus the column number. This is a power. Remember, once a number has an even power, if it's a negative, it gives a positive. If a number has an odd power, if number is a negative, it gives a negative. So now let's see. Let's prove for row number 1. Okay, let's see. Like here. Let's prove for this. Where is it? It is on column number 1. So, okay, which row? It is on row number 1. So that is 1 plus. That is row number 1. It is on row number 1. Then which column? Column number 1. Column number 1. So column number 1. So 1 plus 1 will give us 2. So therefore negative 1 squared, it will give you positive 1. That's why here it is a positive. Okay, good. Then let's also proceed. All right. Let's now go to J, the interesting J. Now for this part, you realize that J is on the second column. So J is on the second column. The column side, I'll put a 2. But on which row? In the first row, add 1 plus 2 will be a 3. So therefore, shall have negative 1 power 3. When you add that on a calculator, you get a negative 1. So first, what we see is a sign. That's the reason why we attach here a negative, natural negative. But for you, don't need to do this. You just need to go direct. Just know there exists a natural negative on that part. Let's prove for the last one. This one here, the K. Now K in terms for K, like we have negative 1, K is on which row? Is on row number 3, rather on column number 3, plus which row is that K? Which row or which row is that K? Okay, find that the K is on row number 1 also. We use this one here, row number 1. So then if you realize that it will now be plus 1. Now we shall have a negative 1 power 4. And a negative 1 power 4, you get a positive. That's why you have it as that. But our aim was about why that one is a negative. We are still proceeding. Let us proceed. All right, good. So let's now proceed with our lesson 2. They're saying, okay, the angle between the two vectors. Now, the next part, remember, we have looked at the dot and cross product. Now, I want to see the applications of dot product, or how do we use the dot product in vectors? Where will we apply the dot product and where will we apply the cross product? To begin with, angle between two vectors, and to find the angle between two vectors, we use the dot product. We use the dotting process to get us that. And now the formula says, when you have A dot B, angle between two vectors, A dot B will be equal to magnitude of A, magnitude, this is a side multiplication there, magnitude of B, equals of theta. So just have to memorize this formula, though some of these formulas are provided in the logbook. So realize that we need to dot A dot B, like that, so now shall say solution. Solution. So now we know that vector A is equal to, okay, from here, 4, negative 2, 1. Now if it is K, the coefficient is 1, so 1, comma. All right. B vector will be equal to, Okay, now since our formula bears the magnitudes, let's be getting the magnitudes at once. So we need the magnitude of A. So I come forward and I say magnitude of A will be the same as what? Magnitude of A will be the same as this. A 4 squared plus a negative 2 squared plus, right. Oh, this is not K, it is a 1, sorry. It is a 1, so 1 squared. With this, shall be able to get the magnitude of A in simple terms. Then also this side, you can be pressing this and calculate and you see. So magnitude of, rather, B vector equals to 3, 4, 2, like that. Now magnitude of B equals to a square root of 3 squared plus 4 squared plus 2 squared. Now let's square here. Now what will be the magnitude of B? Why am I calculating this? It's because in the formula I need magnitude of A and I need magnitude of B. So I began by calculating that first of all. Let's now see on your calculator, you press. Okay, we have, that is all right, we have 4 squared plus negative 2 squared. That will be 4.5826. Or rather, you can even put it in root format. You can leave it as a root to be just a root of 21 to such that your answer can be accurate. A root of 21. Then also 3 squared plus 4 squared plus 2 squared will be a root of 29. Please, you always leave them in root form for accuracy. Now let's proceed. Now what next? Are you seeing in this formula we have magnitude of this, we have them. Then what is next? The dotting. The A dot B, we don't have it. So we come and say here that, okay, A dot B will be equal to, what are we going to have there? So 4, negative 2, 1, dot. Okay, we have 3, 4, 2. 3, 4, 2. Okay, let's go about the dotting. When you dot, what shall we have in the end? 4 times 3 will be 12, plus negative 2 times 4 will be negative 8, plus 1 times 2 is 2. Which answer shall we have in the end there? Okay, I think the answer shall have here will just be 6 after dotting. You can just be kind about that. Okay, I think the answer will be 6. You can also prove that. Now, since you have everything, now we come and say from A dot B is equal to magnitude of A, magnitude of B, cos of theta. Now, the A dot B is 6 is equal to magnitude of A is root 21 times root 29, a cos of theta. So you realize that you will divide both sides by a root 21 times, okay, times, there is a multiplication there, a root 29, dividing. Then also this side by root 21 root 29, like that. So this will go with that, this will go with that. So you have it that now a cos of theta will be equal to, a 6 over root of, now root 21 times root 29 will be the same as 21 times 29 in simple terms. Let's conclude. So now I shall say that theta is equal to a cos inverse of this whole stuff. It can be pressed in the calculator, so let me just put it direct. A root of 21 times 29. So what will be our theta? That theta must be to 1 decimal place. And when you get the inverse, okay, we press cos inverse of 6 over 21 under root times 29. The answer we have is 75.9. The answer we have is 75.9 degrees. These angles are reported to 1 decimal place. Good. Let's now come to this. So that's the angle between. We use the dotting. Let's now come to this. We have P is equal to that and Q is equal to that. They want the angle between this. So shall now say solution. Now here we were using A and B, but you can as well edit it as P. So P dot Q is equal to magnitude of Q. Rather, can start magnitude of P, then magnitude of Q a cos of theta. Please don't change this to sine. They can't give you the same answer. All right, good. So some people prefer going direct, like they just substitute here, whereby it will be like this. Oh, some people prefer going it direct equals to. Now, what's the P? The P is 2. Now, it is I, but going to K, meaning that the J is not there, it is a 0, then a 1. 2 in the I, that is 2. The J is not there, so 0, then K is a 1. So we have 4, a 5, and a 2. Please, I'm substituting in the formula. P is here, Q is here. Now, your magnitude of P will just be a square root of this guy squared. 2 squared plus 0. You can go direct like this, or you can use that first method. Plus, okay, 1 squared. That's just in 1 root. Multiply by a square root again for magnitude of this. It will be 4 squared plus 5 squared plus 2 squared. But a cos of theta. Let's go about the dotting. 2 times 4 is 8 plus 0 times 5 is 0. 1 times 2 is 2. Okay, we are dotting and we all know how to dot. Then here we have a square root of 5 because 2 squared is 4 plus 1 is 5. Okay, square root of, let's square here. We're having a 16 plus 25. So you have a 16 plus a 2 and a 5. So be a 1, 41 plus 4. So you have 45, but a cos of theta. Simple trick. Come and divide by side by root 5, root 45. Both sides. Oh, I didn't simplify this. So now this one will be, let's simplify here. 8 plus 2 is a 10, which is equal to, then multiply these two, they will just be the same as a root of 5 times 45, a cos of theta. Divide both sides by this, root of 5 times 45. Why I'm doing this, please, in indices, this is acceptable. You have a root of A times a root of B. This will be the same as a root AB. That's what I'm using. So divide both sides by that. That will be root 5, root 45, please. Okay. Is a square root of 5 times 45. A square root of 5 times 45. This and that goes away. Then what are we going to have? Shall have that now a cos of theta is equal to a 10 over a square root of 5 times 45. So theta will be equal to, it can be pressed in the calculator, cos inverse of 10 over a square root of 5 times 45. And now what will be your theta to 1 decimal place? In your calculator, so you have a cos inverse of oh, by the way, you change this to 5. Change this to 5 so that our answer can easily come out. Change that to 5. All right, so now be a cos inverse. Okay, we have a cos inverse of oh, 5 times 45. Cos inverse have 48.2. 48.2 degrees, and as simple as that. That's how we get the angle between two vectors, or an application of the dot and cross product. Let's move on. All right, good. So let's see. Wind up with lesson 2. We are winding up with lesson 2 with this example. So in the more examples, they are saying, we look at the applications of the dot and cross product. The dot you have seen, we use it to find the angle between two vectors. Now let's see. how to use the cross product. Now they're saying find the vector perpendicular. Find the vector perpendicular. Now the word perpendicular means at 90 degrees. So a vector perpendicular means that they should be like this. Find a vector perpendicular to that. Now, perpendicular means at 90 degrees. That's what it means. Okay, find the vector perpendicular to both. And now in vectors, we shall respect the word perpendicular and also respect the word parallel. Please. These two words must be respected. Perpendicular, parallel. Okay, good. Now, find the vector perpendicular to both. We have A is equal to 2 in the I plus 3 in the J plus 3 in the K, and B is equal to -1 in the I minus 2 in the J. They want us to get a vector which is perpendicular to that. Now we shall say that to get a perpendicular vector, comma, then cross the two vectors. Shall say solution. This is the first thing you must know. Please take note of the things you are writing here. So to say to get a perpendicular vector, to get a perpendicular vector, comma, then cross the two vectors. I write cross in capital letters. Then cross. You all know how to cross the two vectors. Then cross the two vectors. Then cross the two vectors. All right, now let's do the crossing. Now we all know that if this one is our A is equal to 2, 3, and our B is equal to, now here, a -1 in the I, -1. The J is not there, so 0, then -2. Okay, we cross these two guys. After crossing them, we shall get a vector which is at 90 degrees with these two. That's what I'm meaning, a vector which is at 90 degrees with these two. All right, good. So let's go about the crossing. So crossing, I'll just get those guys and cross them. So we shall have vector A cross vector B. They will give us a normal vector or a perpendicular vector. Normal, perpendicular, they are the same. So this will be 2, 3. Okay, 3. All right. Then you shall have -1, 0, -2. Oh, we are crossing. Right. Now in the crossing, still our piece of paper will come back. In the crossing, still our piece of paper will come back. Now, remember, okay, cover up this. When you cover up that part up, what do you mean with? Minor diagonal, major diagonal has -2 times 3, which should be a -6. -6 minus, of course, we are getting the determinant. You can rewind the video backwards so you can learn how we go about the crossing. Now, I'm done with that minus. Now, with 3 times 0 will just be a 0. All right, good. So we go to the next level. Now, next level, you just know, naturally, there is a negative there before you bring the values. There's a negative there, so shall have, okay, major diagonal is -2 times 2 will be -4 plus, minor diagonal is -3 times it is a minus, the minus of the formula for major diagonal. So -3 times -1, rather 3 times -1 will be -3. Shall harmonize that, then we come down. Okay, cover up this. We have 0 times 2 will be 0 minus 3 times 1 will be -3. Then finally, you can get us that answer. So this will be -6. Now in here we have, when you look at these two, you multiply them, negative times negative will give you a positive. So therefore, -4 plus 3 will be a -1. Then here 0 minus -3, this becomes a positive. After applying, will give you just a 3, like that. Then the negative, so we have the answer is -6 and -3, -6, -1, and 3. Now this is the vector which is perpendicular to those, vector A and vector B, and we have gotten it by just crossing, and that's an application of the cross product. We use it to change two vectors into a normal vector, or we can use the cross product to change two vectors into perpendicular vectors. Perpendicular means they are at 90 degrees. As simple as that. If you want to write it in this format, I know someone may want to write it in this format. So if you want to write it in the IJK format, it will be -6 in the I, okay, -1 in the J, plus 3 in the K. If you want it in that format anyway, you put those wavy lines. As simple as that.